Hello, Selena and Abby are here with me to share yet another geometry word. Now, this one is my favorite, and I think that it might be your favorite too, because this one's really fun and there's lots of ways to be creative with this one. So you can see that I have the metal inset material here in front of me. I am going to pull aside a couple pieces for us to look at, and then we'll explore more. So I am going to just slide these ones to the side and bring out our whiteboard and set right here. Okay, now we have our square, and then here we have our two congruent triangles that we explored in our congruent lesson, and then we have two rectangles which are also congruent. They both fit in their space. Two of them fit in there. So I want to explore a little bit with what is happening here. We know that this is one big square, so I'm going to set it out. And here we have our two triangles. Now I want to establish that these are all the same, that the material is the same, takes up the same space. So I'm going to move this triangle over and this triangle over. And now we can tell that these two triangles took up the same frame as our one square. We can put our one square there and show it's the same. And then here's our two rectangles. We can put our square over there and show that those squares fit in the same frame. If this isn't a magic trick where we have to wonder, was the material the same size? All of these ones can be replaced out. You just watched that. But I traded them out within their plates. I didn't trade these two. But now you can trust that all of the material fits in all of the frames. So it's not a trick. Okay, how many pieces take up this frame? One. How many pieces take up this frame? Two. Two. And how many pieces take up this space? Two. Two. Okay, so if we know that the frame takes up the same space or needs the same space to fill, and this one takes two and this one takes two, then that must mean that this one and this one take up the same space. That's interesting. So let's think about that. So we're going to look at one piece from here, it took two, and we're going to look at one piece from here that took two. First, what we need to do is fill up this space that's missing because we're going to need a couple more pieces to do this work. So I'm going to slide this down, and I'm not going to be able to slide this down. I'm going to have to move it to the side. We need to fill up this space with some of these other figures. So I'm going to use this one here. That takes up part of it. And then we need to fill this space here. Okay, you didn't see that happen. There it is. I took a piece from here and these pieces from here, and you can see they filled up that empty space in there. So these pieces are filling in the frame, so these pieces must be equal to this. They're the same as this. And we still just have our one triangle from this side. Now I need a little bit of room for my magic here, so I'm going to slide those up out of the way. So we are trying to prove that these two take up the same space. We think they do because in the frame they took up the same space, right? They took up the same space in the frame. But now we need to prove it for real. Okay, I'm going to move this second triangle down so we can see. So we're saying that these two are the same, which means that these ones here are the same. Okay, so if we're trying to prove that this is the same as this, then we need to make this look like this. Okay, watch. Is it the same? Did it become the same shape and same size? It did. I took this piece that was right up here, making this figure, and I pulled it out and rotated it down, and it made the triangle. And we know that these two here, we learned that word already. They're congruent if they're the same shape, same size, but this wasn't really that shape, right? This is this shape right here.
Or was it this shape to begin with?
It could have been. So we can't, in this case, we can't like break this little corner off and glue it on top, but that's pretty much what we're showing. If it were like this, if this piece could break off, we could break that piece off and glue it on up here, it would take that shape. Okay, so I'm going to clear some of this off of our space because I have the new word for what this is called. Two figures that take up the same space, right? When we talked about they took up the same space in the frame. Two figures that take up the same space are called equivalent. These two figures are equivalent. When we rearrange their shape, they take up the same space. These are equivalent. And in that word equivalent, you might be hearing another word you already know. What word do you hear in equivalent? Equal. Equa means the same, and valere, the Latin for that. Valent, valere means value. Equal value. Equus means the same, and valere means value. So equivalent means equal valere, or same value. Not the same shape. These, we can make them into the same shape because they have the same space, but it doesn't have to be the same shape to be equivalent. I'm going to draw this. And, you know, mathematicians and their symbols, you already know the symbol for equivalent. That you didn't know that the symbol you already use in so many other ways is the symbol for equivalent. It's this one. Equivalent. Okay, same space. Can't see that. Same space, there you go. Same space. So you can do so much exploration with different figures that take up the same space. You can cut things out of paper and rearrange them till they're the same, take up the same space, make the same shape. You can cut two things out that start the same, cut them and make completely different figures with them. We can do that with the material, and I know you don't have the material at home, but with this, we could look at pieces that are equivalent and change the way they look. So we know that these were equivalent. We know that this square, these two triangles take up the same. So we could change them and do that. And we could say these two figures are equivalent. We could turn them and do them this direction and say these two figures are equivalent. We could add to both of them. We could make this and that. Those are now equivalent. You can do it with any shape that you're working with. Would either of you like to make an equivalent figure?
Okay.
Abby's going with a small rectangle. Oh, Abby thinks this small rectangle is equivalent.
Wait.
You're right. Abby says this little rectangle is equivalent to that little square.
I don't know if I'm right.
She doesn't know if she's right.
Is there a way we can check it?
There is with fraction work. So if you haven't had fractions yet, you can just like watch this for fun. If you have had fractions, then you can know this is review. So how many pieces fill this frame?
1,
How many fill this frame?
2,
So each of these is a half?
Yeah.
Yes. And there are how many in here?
4,
So each of these is 1/4. How many are in here?
8,
So one of these is an 1/8. And how many are in here?
16,
And so one of these is a 16th. But if we have 2 16ths, it equals 1/8. So let's look here. This is 2
halves,
half. There's 4 pieces, so this is a 4th. And here we have how many pieces?
8,
And this is
8.
1/8. So 1/8 is equal to 2 16ths. Abby did it. She wasn't sure. She thought they were, but she didn't trust herself quite enough. But you can always check it another way. So we know that this one here is a 16th. So these two little guys are equivalent because they came from the same 16ths. But if you took 2 from here, then they equal one of these or one of these. So that was just a little aside for you that have already had some of this work and this isn't new. For those of you who this is new for, it's okay. It's okay. We're just learning and we're practicing and exploring. So equivalent means same value, equal value. And the symbol is your trusty equal sign that you use for all of your other equations. So here we go. Ooh, equivalence. It has an equal sign and it equals valere, equal value. There's a cutout of scrapbook paper and there's some drawings. These shapes are equivalent. These quadrilaterals are equivalent. And equivalent shapes take up the same space. That's the definition. There, take up the same space. Again, I will post a picture of this so you don't have to try to copy it from the video. And for your follow-up, make sure you make a journal page just for equivalence that shares your learning about what equivalent figures are. We're going to do a ton of work with equivalence. In fact, equivalence follows us through pretty much everything we do, not just geometry, but as we get into algebra and we're looking at balancing or finding equations that are equal. Anytime you're using the equal sign, you're learning about equivalence. I hope that you enjoyed this new lesson and your new vocabulary, equivalent or equivalence, and we will see you next time. Bye-bye.